Question 1a here. The first thing we need to do is let z equal x plus yi. And that means that the conjugate would be x minus yi. So if we fill that into what we have here in the question, that means that 2 times x plus yi minus 3 times x minus yi is equal to minus 27 plus 23i over 1 plus I. And we expand out what we have here. So 2x plus 2yi minus 3x plus 3yi will be equal to. Now, when we have a fraction like this with our complex numbers, what we would normally do is multiply top and bottom by the conjugate of the denominator. So we can do that at this stage. We're multiplying top and bottom by 1 minus I. So we need to expand this side. We would end up with minus 27 plus 27i plus 23i minus 23i squared all over 1 minus I plus I minus I squared. Remembering, obviously, as it says in the question there, that I squared is equal to minus 1. So that means that we won't have any complex elements in the denominator of the fraction. So we simplify each side separately. We don't mix the two sides. We want to make the left-hand side equal to the right-hand side, and hopefully that will help us then to figure out what x and y are. So on the left-hand side, we get minus x plus 5yi when we simplify down. And on the right-hand side, the i's on the bottom and the denominator will cancel each other out. Minus I squared is going to be minus 1. Okay, in the top, we can just bring the i's together. So we get minus 27 plus 50i plus 23. Now, you could obviously bring the minus 27 and the plus 23 together there straight away if you want. By the way, I'm getting plus 23 because I've replaced the a squared with minus 1. And then on the bottom, you would have 1 minus 1. So I'm taking a little bit more of a step here just to make sure I get it right. So minus x plus 5yi will be equal to minus 4 plus 50i all over 2. And that simplifies down, just looking at that right-hand side, that would simplify down as well to minus 2 plus 25i. So what I have here is I have a left-hand side of minus x plus 5yi equal to the right-hand side of minus 2 plus 25i. So what we can do is we can look at the real elements and we can put them equal to each other. So we can say minus x is equal to minus 2. So therefore x is equal to 2. Okay, which helps us. And we can do the same with the imaginary parts. The 5y is equal to 25. So y is equal to 5. So if x is equal to 2 and y is equal to 5, then z can be written in the form of 2 plus 5i. That's my final answer there, and that's worth 10 marks. Right, question 1b, the first thing we need to do here is to find the modulus of z cubed. So the modulus of z cubed, what we would have is the square root of minus 4 to be squared plus 4 root 3 to be squared. When we work that out, we end up with 16 plus 16 times 3. So it ends up being the square root of 64, which is equal to 8. So the modulus is 8. So if we wanted to here, we could do a little bit of a quick sketch of an Argand diagram, what this would look like. So z cubed would be somewhere over here. So we're looking at it being 4 on the real axis, and on the imaginary axis, we're looking at it being at a height of 4 root 3. Okay, so minus 4 plus plus 4 root 3. And what we've just figured out there is that the modulus, which is the distance here from the origin, is 8. So the next thing that we need to figure out is our angle. And the angle we're actually looking for here is this. So this is the theta that we're looking for. But in order to find that angle, then realistically the easiest way is to first of all find out what this angle is in here. So for example, if I call it x, then we can use our sine cos tan to help us with that. So if I want to find out what x is, well, we would say that maybe the tan of x will be equal to 4 root 3 over 4, opposite over adjacent. So x would be equal to the tan inverse of 4 root 3 over 4. You could use the hypotenuse of 8 as well. In theory there shouldn't be fine. So x is equal to 60 degrees. So if x is equal to 60 degrees, well then our angle of theta must be equal to 120 degrees. So we have 8 as our modulus and then 120 is our argument. So now we need to start putting it into polar form, general polar form. So what we can say is that z cubed is equal to 8 times the cos of 120 plus I sine 120. But we want it to be also in general polar form. So we obviously need to change this to have, now obviously this is done in degrees, you can also do this in radians. So we have to also include the idea or the understanding that cosine and sine are periodic functions. So they have a period of 360 degrees or 2 pi if you're using radians. So when we're looking at our general polar form, we're also going to include that in. So we're looking at it being, so Z3, so power 3 is equal to 8 times cos of 120 plus 360n plus I sine 120 plus 360n. Now, what we have here is z cubed. We want to find z, so we cube root. So cube root of 8 is 2, and we cube root everything else as well in here. So we end up with the cos of 40 plus 120n plus I sine 40 plus 120n. Now that's where I've used De Moivre's theorem, so the idea would be that you're putting 8 to the power of a third, which is the same as a cube root, and you're also putting all of this bracket here equal to the power of a third. And when we do that, we can use De Moivre's theorem to bring down the third, and you're multiplying it into your bracket here for your angle. So basically we're dividing 120 by 3, 360 by 3, and the same here. That's where we've used De Moivre's theorem. So using what we've got there for z, we now need to go in and look at, we're asked to find the 3 roots. So when n is equal to 0, when n is equal to 1, and when n is equal to 2. So when n is equal to 0, so z1 will be 2 times the cos of 40 plus I sine 40. Because our 120 multiplied by 0 disappears. For n equals 1, so z2, we would have 2 times the cos of 160 plus I sine 160. So again, replacing the n with 1. And the last one when n is equal to 2, so z3. So we get 2 times the cos of 280 plus I sine 280. And those are our 3 roots, so z1, z2, z3 in general polar form. And that question was worth 10 marks. Part 2 then is asking us to plot and label the three roots Z1, Z2, Z3 that we've just found in B part 1. So let's just remind ourselves of what they are. So Z1 is 2 and cos 40 plus I sine 40. Z2 is 2 cos 160 plus I sine 160. And again, you might have this done in radian form as well. So 2 cos 280 for Z3 plus I sine 280. Okay, so we're going to plot these on an Argand diagram. As long as we have a straight edge, we draw our imaginary and we draw our real axes here. And we label them. So, first of all, starting off with what we have here. So the 2 here represents the modulus, so that's going to be the distance from the origin, right there. And we have our argument, so our 40-degree angle for the first one, for example. So we're going to have a 40-degree angle. I mean, you can, if you want to, use a protractor. It just happens to be the straight edge that I'm using. So 40 degrees. Now we're going to draw our line there. So this is going to be how I represent my Z1. That's going to be my modulus of 2. And there's my angle of 40 degrees. So Z2 then, again, has the same modulus. This time we're looking at an argument of an angle of 160. So again, we're going to use a protractor just so we get a little bit of accuracy. 160 is over there. And again, we have to have the same modulus. So as best as we can, we have the same modulus. And again, that's going to be a modulus of 2. And again, that's 160. So in here would be 120 if I wanted to mark it. And then Z3. So Z3, sorry, let me just label that. Z2. Z3, again, modulus of 2. This time we're looking at an angle of 280. Easiest way for us to get an idea of where that's going to be, it's going to be somewhere down here in this quadrant. 280 would be taking away 80 degrees from 360, so we could just measure an angle of 80 degrees coming back this way, somewhere in line with here. And again, the modulus must be the same, so the length of my line should be about the same. So that's where my Z3 is. Now, it's asking me to then hence find the area of the triangle Z1, Z2, Z3. So the next thing I would do is just join up those vertex so we can see the triangle that we have. And again, remember that that was a modulus of 2 as well. So what we hopefully see from this is we have 3 triangles that are making up the space that we have here, the complete triangle. We have 3 isosceles triangles where we have lengths of 2 being equal. And what we're going to do to find the area, we'll get the area of one of those triangles. So we're going to use our area formula. Because we have the side measurements and we have an angle in between, we're going to use a half AB side C. So in each individual, I mean, you can do the multiplication by 3 straight away if you wanted to, but if not, we're just looking at a half times 2 times 2, and it's the sine of the angle in between. The angle in between in each one is this 120 angle. Okay, it's going to be 120 no matter where we look at here. It's complete angle between those two moduluses that we have. So my sine of 120 degrees is what we're going to put in there, which is going to give me, when I put that into the calculator, root 3 as my answer. So that's the area of one of those isosceles triangles. We obviously have 3 of them, so we're timesing that by 3. So the total area that we have that's made up of the triangle Z1, Z2, Z3 is 3 root 3 units squared. And that was 10 marks. So question 2 gives us that a radio quiz show pays contestants €100 for for their first correct answer. Each subsequent correct answer results in an increase of €50 per question. So we're looking at the first question giving us 100, the next one would be 150, then you'd add on 200, 250, and so on. So in this particular question, they tell me that a contestant, Sean, won a total of €5,200, and we're asked how many questions did Sean answer correctly. So here we have basically an arithmetic sequence that we're adding together. So we're looking at sum of an arithmetic sequence. We're going to use our formula from page 22 in our log tables book. So where we would have A is 100 and our difference is 50. So we fill in. N is basically what we're looking to find. Okay, what question does he get to? How many questions does he actually get to? So we're looking at 2 multiplied by A, which is in this case 100, plus N minus 1 times D, the difference, which is 50. So we're filling into that formula. And when we work that out, we get N over 2 times 200 plus 50N minus 50. Now we know that the answer, or what he actually earned, was €5,200. So we put that equal to €5,200. We can add or bring our 200 and our minus 50 together. So we get 150 plus 50N inside our bracket. We could divide in the 2 and get rid of the n over 2, not have a fraction. So 5,200 is equal to n times, or dividing the 150 and the 50 by 2, so we get 75 plus 25n. And then multiplying in the n. So 5,200 is equal to 75n plus 25n squared. And here we're going to get a quadratic, bring the quadratic all to one side. So 0 is equal to, keep it positive, 25n squared plus 75n minus 5,200. And we look, if we can, to simplify that down. We could actually divide across by 25 here, make it nice and straightforward, hopefully. So we end up with n squared plus 3n minus 208. And we could look to factorize that. Again, you could use your quadratic formula if you wanted to, but in this case, factorizing should be fine. So we open up our brackets. We're going to have n minus 13 and n plus 16 in our brackets here. So n minus 13 is equal to 0, so n is equal to 13, and n plus 16 is equal to 0, so n is equal to minus 16. And in this case, if we look back at the question, we're talking about how many questions that Sean answered correctly. I mean, minus 16 doesn't make sense in that kind of question. So the only answer that's going to make sense for this question is that he answered 13 questions. And that was 10 marks. So question 2b, part 1, it gives us these three terms, the first three terms in a geometric sequence. We're asked to show that k satisfies the equation. So if we have a geometric sequence, we should understand that if I was to divide the second term by the first, or the third term by the second term, we should end up with the same answer. So we're going to use that to help us answer this question. So second term is 12 minus 3k, and if I divide that by the first term, which is 3k plus 4, it's going to have the same answer as if I divided the third term, which is k plus 16, by the second term. So we can put those equal to each other, and the idea then would be to try and work it out and get to a point where we have this quadratic equal to 0. So we have two algebraic fractions equal to each other. What I can do is cross multiply and bring the denominators over to the other side. So I end up with 12 minus 3k from the top here. Bring over the 12 minus 3k that's in the denominator on the other side. And on the right hand side, k plus 16, bring over that denominator multiplied by 3k plus 4. So a lot of expanding that we have to do. We get 144 minus 36k minus 36k and a plus 9k squared on the left hand side, and on the right hand side 3k squared plus 4k plus 48k plus 64. And we could try and bring that all to one side. Okay, so if we bring it all to the left hand side, 9k squared, take away the 3k squared is going to leave me with 6k squared. Here we have a minus 36k, and here we're going to bring that over. It's going to be minus 4k and a minus 48k, which is going to leave me with minus 124k. And we have 144, take away the 64, is going to leave me with a plus 80 equals to 0. You can take your time a little bit more with that if you want. That's what we should end up with. Obviously not the exact same as the answer, but if we look at it and we divide by 2, we should end up with the same quadratic in the question. So if I divide that by 2, we get 3k squared minus 62k and a plus 40 equals to 0. And that's my answer. And that was 10. So question 2b part 2 here asks me to find the value of k for which the sum to infinity of the series exists. So the first thing I'm going to do is take the quadratic from the question above, and I'm going to solve for k. So in solving for k, you could factorize, you could use a quadratic formula. I'm going to factorize. We get 3k minus 2 in one bracket and k minus 20 in the other bracket equal to 0. So 3k is equal to 2, k is equal to 2 over 3 is one of my solutions, and k equals 20 will be my other solution. So we're looking at a situation where we fill this into our sum to infinity for the series, but the first thing we need to do is work out our common ratio. In order for us to use our sum to infinity formula, if we remember from page 22 in our log tables book, we have our common ratio here, and in the log tables book as well, they tell me that the absolute value of this needs to be less than 1. So we're looking for r to be negative basically here. So when I fill in my k value, and I can use one of the fractions that I had previously in the top question. So for example, 12 minus 3k over the 3k plus 4. And if I fill in both my values of k, I'm looking for a situation where I get this less than 1. So if I fill in for 2 over 3 first, 12 minus 3 times 2 over 3 over 3 times 2 over 3 plus 4. And we can work that out. We end up with 12 minus 2 over 2 plus 4, which ends up being 10 over 6, which is 5 over 3. Now that's positive. That is a situation where it's greater than 1, so that's not going to work out for this question. Sum to infinity doesn't exist in that situation. So we're more than likely going to use k equals 20. So k equals 20 is going to give me an r value, and we need to check what that is. So we're going to fill in 20 instead of 2 over 3. So 3 times 20 plus 4. Okay, when we do that, we get 12 minus 60 over 60 plus 4. So we end up with a minus 48 over 64, which simplifies down to minus 3 over 4. And again, that's the situation that we wanted. We have our r is less than 1. So we fill into our sum to infinity formula. Our a is our first term, so given to us in the question, that was 3k plus 4 over 1 minus r, and our r value that we just found there is minus 3 over 4. And when we put that in, we're using our k value of 20, remember, as well. Could have put that in straight away if I wanted to. Our double negative on the bottom will give me a positive, and we end up with 64 over 7 over 4, which put that into a calculator, 256 over 7. That's my answer. And that question was worth 10 marks. So question 3, we're asked to solve the following inequality. So the first thing we would have to do here, we have an algebraic fraction. We need to get rid of the algebraic fraction. And the best way to do that is to multiply both sides of the inequality by the algebraic denominator squared. So that's going to look something like this. So we're going to have x minus 2 over x plus 3, but we're going to multiply that by x plus 3 to be squared, greater than or equal to a half. And again, we need to multiply the other side by the same denominator squared. So we need to multiply that out. This bottom denominator will cancel with one of those brackets that we're going to multiply in. So we're just left with x minus 2 times x plus 3 on the left-hand side, greater than or equal to, and here on this side we'll have to expand out that. So x plus 3 to be squared will give me x squared plus 6x plus 9. And we keep going. What we can do here is we can eliminate that half. I suppose multiply both sides by 2 would be the best way of doing that. So again, we would just show that on the left-hand side, we're multiplying by 2. You could multiply out these brackets a little bit quicker than I am as well if you wanted to. And then we've left with x squared plus 6x plus 9. So multiplying out the left-hand side, you'll have 2 multiplied by x squared plus x minus 6. Again, you could have done that a little bit sooner. And the right-hand side stays the same for a moment. And that gives me then 2x squared plus 2x minus 12 greater than or equal to x squared plus 6x plus 9. So we want to solve this, so we need to get everything to the same side. So if I bring everything to the left-hand side, we'll end up with x squared minus 4x minus 21 is greater than or equal to 0. So we have to solve that quadratic. And when we solve it, we can factorize it, and it'll factorize with brackets of x minus 7 and x plus 3. And then if I was going to solve that, we would say that x would be equal to 7 and x would be equal to minus 3. So sort of ignoring the fact that it's an inequality for a second and solving it as if it was an equation. A little sketch of what that would look like. So this quadratic here, it's a positive quadratic, and what it's telling me here, its solutions are 7 and minus 3. So it's hitting the x-axis at minus 3 and positive 7. And when we're talking about solving this quadratic, it's a quadratic inequality. That's where the quadratic is greater than or equal to 0 means above the x-axis. So everything above the x-axis will be continuing there to the left, and then over here continuing to the right. So that would mean that x would have to be less than minus 3. Now the reason why it's not equal to minus 3 is because in the question it tells me x can be equal to. Otherwise we would put the or equal to sign as well. And then x is greater than or equal to 7. That one we can include the or equal to because there's nothing in the question that tells me otherwise. And that's my answer. And that would be 10 marks from the question. Question 3b, we're given this function and we're asked to prove that the roots of f of x equals 0 are real for all m elements of the real numbers. So if the roots are real, then what we need to understand is our discriminant, which is our b squared minus 4ac, is greater than or equal to 0. So we need to look at what's our b. So in this case, our b is equal to the minus, don't forget the minus, it's minus 1 plus m in the bracket. So it's the x coefficient is my b. My a is always the coefficient of my x squared. So that in this case is 1. And my c is everything here on the end. And don't forget the minus. So it'll be minus 6 times 1 plus n to be squared. So that's the first thing to work out. What you could do here is do a little bit of expanding out of that. So you're looking at that being minus 6 times m squared plus 2m plus 1. And you could work that out as minus 6m squared minus 12m minus 6. It just might help you out later on. So if I'm filling into my b squared minus 4ac, that's what I need to fill into. So b squared minus 4ac in this case will be equal to, now don't forget when you're squaring the b, it's going to be squaring that negative as well. So a little square bracket around it might help. So it's minus bracket 1 plus m to be squared. Then minus 4 times a, which is 1, and then c, which we already have, is minus 6m squared minus 12m minus 6. And we try and work that out as best we can. So when I square a negative, I'll actually end up with a positive, so it works out okay. So that'll give me m squared plus 2m plus 1. And then we have, well, we've minus 4. The 1 we can sort of ignore because it's not going to make any difference. But minus by minus will only give me a plus 24m squared. We'll end up with a plus 48m and also a plus 24 on the end. So really important that we don't forget about those minuses in our multiplication. And we tidy that up, we'll end up with 25m squared plus 50m plus 25. So that's our discriminant. And we have to be able to say that that is positive, basically, greater than or equal to 0. Well, if it's positive, can I factorize in any way? Can I show that it's positive? I can take a 25 out here, and I'm left with m squared plus 2m plus 1. And I can actually factorize that as well. And again, could end up with 25 times m plus 1 to be squared. 25 is obviously positive, and you're multiplying something here that is squared. And anything that is squared will always be positive as well. Even if m was negative there, it would end up with a positive answer when you square it. So we can say that b squared minus 4ac is greater than or equal to 0, and that proves there are real roots. And that question is worth 5 marks. Question 3b, part 2. So they're asking us to hence express the roots of f of x equals 0 in terms of m in their simplest form. So the best way for us to find the roots, I suppose, would be to fill into our minus b formula. So that will give me x is equal to minus our b. So our b, remember, was minus bracket 1 plus m. I suppose you could multiply in that minus if you wanted to straight away, plus or minus the square root of, now this is a discriminant, so we can just use, and that's why they use hence, we can just use our answer from the previous question, which is helpful, and all over 2a, which is 2 times 1. So when I work out what I can work out there, the 2 double negative here will make it positive, so it's 1 plus m plus or minus square root of this. Well, square root of 25 is 5. Square root of the bracket being squared will just be m plus 1, and that's all over 2. And we can take the positive side and the negative side here to find our roots. So x is equal to 1 plus m plus the 5 times m plus 1. Again, you can multiply that out straight away. Or x is equal to 1 plus m minus the 5 times m plus 1. Just be careful about multiplying in the minus. So x will be equal, and again, sorry, they're both over 2. So when we multiply those out and tidy it up, we end up with 6 plus 6m over 2. So we multiply here, we get 5m plus 5. Over here, maybe we take a little bit more time on what we're doing. So it's 1 plus m minus 5m minus 5 all over 2. Just be a little bit careful about the negative. So we end up with minus 2 minus 2m over here. And on this side, it's 3 plus 3m. And they ask for it in their simplest form. So we could look at factorizing here and taking the 3 out, for example. 3 multiplied by 1 plus m. On this side, we could take a minus 2 out and 1 plus m in a bracket as well. And that is 5 marks. Question 3c is asking us to solve the simultaneous equations. So let's have a look at what we have. We have a linear equation on the top. And we also have P and Q here, but we have some fractions, we have some dividing happening in that second equation. So what we would do is take the linear equation, so the 4P plus Q equals 10, and make either P or Q the subject. Q is the easiest one to make the subject then as 10 minus 4P. And what we'll do then is using that linear equation, we'll substitute that into our second equation here. So the 3 over p will stay as it is, minus 4 over q, this time instead of q, putting 10 minus 4p. equals 1. So now that we just have p's in this equation, and hopefully we can work this out and solve for p. Two fractions being subtracted, so let's get a common denominator. Common denominator is going to be p multiplied by 10 minus 4p, minus 10. So common denominator is t multiplied by 10 minus 4p here to bring these two fractions together. We're subtracting equal to 1. So getting our numerator on the top, it's going to be 3 multiplied by 10 minus 4p minus 4 times p. And that brings our fractions together. After that, then, we can eliminate the fraction. We can multiply both sides by the denominator that's here, bringing it up over to the other side. So we end up with 3 multiplied by 10 minus 4p minus the 4p equals, and then 1 times p times 10 minus 4p. Okay, so we've eliminated the fraction there. And what we can do then is multiply that out. You could have done that before now, but we can multiply it out now. So we get 30 minus 12p minus 4p on the left-hand side. On the right-hand side, 10p minus 4p squared. We need to bring that all to one side. We're going to make it into a quadratic equation that we're going to solve. So we'll get 4p squared minus 26p plus 30 equals to 0. You could look to factorize that as it is. You could divide both sides basically by 2, make it a little bit easier. 2p squared minus 13p plus 15 equals 0. Maybe a little bit easier to factorize. You could use your quadratic formula as well. It does factorize to 2p minus 3 in one bracket and p minus 5 in the other bracket. When we solve, so we get 2p is equal to 3, p is equal to 3 over 2, or p is equal to 5. So those are our two solutions for p. And what we need to do is use those and go back into our equation up here for q. So the first one there, q is equal to 10 minus 4. Instead of p, I'm going to put in 3 over 2. When we work that out, you can use your calculator if you want. We'll end up with q is equal to 4. And on the other one, q is going to be equal to 10 minus 4 times 5. So q is equal to minus 10. And there we have two solutions for p and two solutions for q. And that was 10 marks for that question. Question 4a, we're asked to differentiate sine squared 3x with respect to x when x is equal to pi over 12. We're also then to find the value. So the first thing we're going to do is differentiate. The first thing I would do is change that to sine of 3x all to the power of 2. So we're going to use the chain rule twice here, really. First thing we're going to do is find the derivative of the power. So that means we're going to bring 2 down times sine of 3x. Then we're going to find the derivative of sine of 3x, which is going to be cos of 3x. And then we find the derivative of the actual angle, so 3x, which is going to be 3. So we can do the chain rule all in one go there. There's no need for substitution. Suppose we can multiply the 2 and the 3 together, so we would get a final answer there of 6 sine 3x cos 3x. And it asks us to find the value when x is pi over 12. So filling in, instead of our x, pi over 12. Of course, you can cancel here the 3 and the 12 will divide if you wanted to. So you're looking at the sine of pi over 4, cos pi over 4. And when we put that into our calculator, sine of pi over 4, cos of pi over 4 is actually 1 over root 2. Root 2, which is works out as 6 over 2 altogether, or 3 is our final answer. And that was worth 5 marks. P gives us this function v of x, and what we're told is the first thing is that it passes through the point 2,4, has a local maximum and local minimum points at x equals 1 and x equals 5 respectively, and we're asked to find the values of a, b, and c. So let's deal with the first piece of information. It tells me that it passes through the point 2,4. So that means that when x is 2, y is 4. So we put in the value of 2 instead of our x. And what we understand from the question is that my answer to that should be 4. So I put it equal to 4. So that gives me 8 plus 4a plus 2b plus c equals 4. All we can do then is bring the 8 and the 4 together. I'll bring it to one side. It doesn't really matter. You could bring just the numbers on the right hand side if you wanted to. But we end up with 4a plus 2b plus c plus 4 equals 0. So that's our first equation. What I would figure here is that we're going to have 3 different equations in terms of a, b, and c that are going to help us to solve. So the next piece of information that I'm told is that it has local maximum and local minimum points at x equals 1 and x equals 5. Now, the first thing we need to do here is figure out what is our differential. Okay, so v times x in this case will be equal to 3x squared plus 2ax plus b. We need that first then before we put in our values of x is 1 and x is 5 into that. So v dash of 1 will be 3 times 1 to be squared plus 2a times 1 plus b. And we understand that will equal 0 because they're telling me it's the local maximum and minimum points. So we get 3 plus 2a plus b equals 0. That's our second equation. That's going to help us. And the next one then we fill in our value of 5. So 3 times 5 to be squared plus 2a times 5 plus b, and again equals 0. So we have 75 plus 10a plus b equals 0. And again, that's our third equation that's going to help us. So what we're going to look at first is these two equations just have two unknowns, a and b, and we can use simultaneous equations with these to help us. So what we can do is line them up first. I'm going to put the 75 plus 10a plus b on top equal to 0. And here I'm going to have 3 plus 2a plus b equals 0. So using simultaneous equations, our b's are the same. So all I would do is multiply the bottom line by minus 1. That will change our signs all the way along. So I get a minus 3, minus 2a, and minus b. The b's will cancel, and we end up with 72 plus 8a equals 0. So 8a equals a minus 72. A is equal to minus 9. So here's my first answer. A is equal to minus 9. Using that then, I can use one of those two equations, whichever one I want, to find out what b is. So if I fill in here for 3 plus 2 times minus 9 plus b equals 0, we end up with 3 minus 18 plus b equals 0. So b is equal to 15. And the last thing is we need to figure out what c is, and we're going to use our first equation that we found to help us do that. So if we fill in our values, 4 multiplied by minus 9 plus 2 times 15 plus c plus 4 equals 0. What we end up with is minus 36 plus 30 plus c plus 4 equals 0. And that all works out. That gives me a minus 6 and a plus 4. So minus 6 and a plus 4 gives me a minus 2 plus c equals 0. So c is equal to positive 2. And those are my 3 answers, and the question was worth 10 marks. Part C gives us y equals the log to the base e of 1 plus e to the power of 2x. And asks us to show this. So we need to have the second differential, the first differential, and show what it says there. So the first thing we're going to do is what is dy dx? And we should understand that the natural log or log to the base e of anything when we're differentiating will be 1 over that. So we would have 1 over 1 plus e to the power of 2x. And we also need to multiply that by the differential of what's inside the bracket. 1, obviously, the differential is 0, but here, if we differentiate e to the power of 2x, we would end up with 2e to the power of 2x. And we just need to multiply those together, so we would get 2e to the power of 2x over 1 plus e to the power of 2x. That's my first differential. And the next thing we need to do is our second differential, d2y dx squared. So for this, we're going to use the quotient rule. What we could do is write it as u equal to e to the power of 2x, and v equal 1 plus e to the power of 2x. So when we're looking at it, du dx will be equal to 4e to the power of 2x. And then dv dx will be equal to just 2e to the power of 2x. So when we're bringing that together, this is going to be our second differential. So we're looking at using obviously what our quotient rule on page 28 of your log tables book. So dy dx, or in this case d2y dx squared, will be equal to our v, which is 1 plus e to the power 2x, multiplied by our du dx, which is 4e to the power 2x, minus the u, which is 2e to the power 2x, multiplied by dv dx, which is again 2e to the power 2x. And that's all over our v squared. I'll put a line just to keep that to one side. Our v squared is our 1 plus e to the power 2x, and that is to be squared. So that's just using our quotient rule to work that one out. And we can do a little bit of simplifying then. So what we can do is we can multiply these two together. And multiply all our brackets out basically. So what we end up with is 4e to the power 2x plus 4e to the power 4x minus 4e to the power of 4x all over bracket to be squared. Our 4e to the power 4x cancel each other out, so we're left with 4e to the power 2x over 1 plus e to the power 2x squared. So if I go back then to what it wants me to show, so we have our second differential, we have our first differential, so we're going to fill into what they have on the right and the left hand side here. And we have to show that that's equal to twice the first differential. So first it's our second differential, so our 4e to the power 2x over 1 plus e to the power 2x to be squared, plus our first differential to be squared. So that's going back to our very first answer that we had. So 2e to the power 2x, 1 plus e to the power 2x, and that's to be squared. And we have to show that that's equal to twice the first differential. Which is again our 2e to the power 2x over 1 plus e to the power 2x. Okay, so we work out what we can. So I'm going to square out this second fraction that we have here. So the first fraction for now is just going to stay the same. So here we're going to have 4e to the power 4x over 1 plus e to the power 2x to be squared. which we can see here will come together. And here, if I multiply the 2 in, I'll end up with 4e to the power 2x over 1 plus e to the power 2x. So we can bring these two fractions together. They already have a common denominator. So 1 plus e to the power 2x to be squared is my common denominator. And when I bring them together, I'm adding the top. Okay, so we have to make the left-hand side equal to the right-hand side here. And the obvious thing that we have difference here in our denominators is that it's the same denominator apart from this one is being squared. So how do we get rid of that? Well, we'll probably look to see if we can factorize in any way on the top. What can we take out on the top in the numerator? We can take a 4e to the power of 2x outside, and we end up with 1 plus e to the power of 2x. And that we can see will cancel with one of those brackets that is on the bottom, eliminating the idea of it being squared. And that's how we end up showing that one side will equal the other. Don't need the bracket there. I can write it if I want to. So I've proved there that the left-hand side is equal to the right-hand side, and therefore I've answered the question and I've shown what they've asked me to. And that question is worth 15 marks. Apologies there for not showing it fully on the screen, but hopefully you can see there now. Question 5, part A. Part 1 is giving us the binomial expansion of k plus 2x to the power of 7, and they're asking us to write down the first 5 terms in this expansion. So, using our binomial expansion, starting with 7c0, we have a k to the power of 7 and our 2x to the power of 0. Remember, powers here should always add to give me 7. The next term will be 7c1, and it's k to the power of 6. So we're talking about the first power is going to reduce by 1, the second power is going to increase by 1. So 2x to the power of 1. And we continue on. So it's the first 5 terms. So 7c2, k to the power of 5, and 2x squared. 2 more, so we have 7c3, so k to the power of 4, and 2x to the power of 3. And the last one, we have 7c4, k to the power of 3, and 2x to the power of 4. Okay, and we can use our calculator to help us with this, obviously. So we end up with 7c1 is 1 times k to the power of 7 times 1, because it's 2x to the power of 0, plus 7c1 is 7 times k to the power of 6 times 2x, plus 7c2 is 21 times k to the power of 5 times 4x squared, so we're squaring out the 2x, plus 35 times k to the power of 4 times 8x cubed. And the last one, we also get 35 k cubed and 16x to the power of 4. Multiply out as much as we can, so we end up with k to the power of 7 plus 14 k to the power of 6x plus 84 k to the power of 5x squared plus 280 k to the power of 4x cubed plus 560 k to the power of 3x to the power of 4. Well, that's our first 5 terms in the expansion, and that was worth 5 marks. Question 5a, part 2. So it tells me that the coefficient of the term containing x to the power of 4 is 15,120. So we're asked to find the value of k. But we've already worked out that our x to the power of 4 coefficient is 560k cubed. Okay, and we put that equal to our 15,120, and we solve for k. So k cubed will be equal to 27, as I divide by 560 on both sides, and cube root of 27 is 3. So my answer is k is equal to 3, and again, that was 5 marks. Question 5b, we're told that x minus 2 to be squared is a factor of this equation, and we're asked to find the values of a and the value of b. So if it's a factor, then it divides in without a remainder. So one way that we can do is to use algebraic division. So the first thing is to expand the x minus 2 to be squared. So x minus 2 to be squared would be x squared minus 4x plus 4. So what we would do is we're going to divide that into our equation that we have here. What you'll notice is there's no x squared term, but we're going to fill in, instead of that, we're going to fill in a plus 0x squared, just to kind of fill the gap, plus the bx plus 4. Doing that is going to mean it's going to just be a little bit easier as we go through it. So we do our algebraic division. So x squared divided into ax cubed is going to go ax times, or we multiply ax by x squared to get ax cubed. So multiplying our x squared, we get ax cubed. Multiply our minus 4x by the ax, we get a plus 4ax, sorry, minus 4ax. And then multiply by the plus 4, we get a plus 4ax. And because we've put that kind of placeholder there of the 0x squared, it just lines up a little bit easier. That should be squared as well. Okay, so we're going to take away everything from here. So if I take away the ax cubed, then they cancel each other. I'm going to take away what's something that's already negative, so it actually ends up being a positive. And I'm going to take away the 4ax as well. So I end up with 4ax squared, and I end up with a plus. Now here we've got, because we don't have any terms that we can actually add or take away together, so we end up with b minus 4a as your coefficient to x. Hopefully that makes sense. And then we bring down our plus 4. And we do the exact same process again. So x squared into 4ax squared is going to be 4a. And we multiply everything by 4a, so 4ax squared, we get a minus 16ax, and then we have a plus 16a. And again, we take away the bottom line, so 4ax squared are going to cancel. Double negative here, which is going to make that a positive, so we're going to add those together, so we end up with the plus 12a, so minus 4a plus the 16a is our x coefficient, and we're going to take away here as well, so we end up with 4 minus 16a. We can't actually take those away, obviously, because we have a number and then an a term as well, so we just treat it like that. Now, if we know that this is a factor, as it tells me in the question, then this is equal to 0 because it has to divide in without any remainder. And this being my remainder must be equal to 0. So if I put that equal to 0, what I can say is that both the x term and the term on the end, which would naturally be a number usually, will both be equal to 0. So you could say that that's equal to 0x plus 0 if you wanted to. So what I can do is actually take the x coefficient and put that equal to 0. And what I can do here is take this term on the end and put that equal to 0 separately. And that makes it a little bit easier because here, with the second term anyway, I can solve for a. So 16a is equal to 4, so a will be equal to 1/4. And once I know what a is, then I can fill back into my other equation that I have here to find out what b is. So 12 times 1/4 instead of the a. So b plus 3 is equal to 0. So b is equal to minus 3. So my a is 1/4, my b is minus 3. And that was 10 marks. Question 5c is a log question. We're told that log to the base 2 of 7 is equal to p, so we're asked to find this expression in terms of p. So we need to look at each of the parts of the terms of this expression and try and manipulate them to be in terms of p. So the first one we're going to look at is log to the base 2 of 14. 14 now can obviously be changed to 2 multiplied by 7. So we're trying to get it to look as much as we can like what we're given. So log to the base 2 of 7 times by 2 is how we can manipulate that. Using our rules of logs then, if we have two things being multiplied here, we can divide that into log to the base 2 of 7 plus log to the base 2 of 2, which would equal p plus 1. P, from what we're given in the question, and log to the base 2 of 2 would have to be 1. The next term then, we have log to the base 2 of the square root of 49 over 8. First thing we understand is that square root means to the power of a half. So log to the base 2 of 49 over 8 to the power of a half is where we would start there. When we have a power on a log like that, we can change it to being multiplied by a half on the front. Okay, so we have a half log to the base 2 of 49 over 8. And then what we can do is, using our rules of log again, we have dividing, we can split that up. So we start over half in the front, and then we'd have log to the base 2 of 49 minus log to the base 2, 8. We can put a bracket around that because it's all being multiplied by the half. And again, keep on manipulating on this 49. We can write that as 7 squared. And 8 we can write as 2 cubed. And again, using our rules of logs, we can bring down that power. So we have a half on the outside. And here we're going to have 2 times the log to the base 2 of 7 minus 3 times the log to the base 2 of 2. So all the time trying to manipulate it to get it to somewhere where we can put in p. Here then log to the base 2 of 7 we can replace with p. So we have a half times 2p. And here minus 3 times log to the base 2 of 2, which is 1. So minus 3 times 1. Again, you could kind of leave out the 1 if you wanted to. Doesn't make any difference there. And that can be changed then finally to p minus 3 over 2 when we multiply in the half. And the last one that we have to manipulate is log to the base 7 of 28. So log to the base 7 of 28 now, it has a base of 7 at the moment. Using our rules of logs here, we can change that base. So we can change that log to the base 2 of 28 and log to the base 2 of 7. And we're using our rules of logs on page 21 to help us with that. So changing that base to 2 then enables me, I can manipulate what we have here. The bottom there is p. So log to the base 2 of 28 could be written as log to the base 2 of 7 multiplied by 4. And the denominator can just be changed to p. And if I continue to manipulate this, I have log to the base 2 of 7 plus log to the base 2 of 4 all over p. Log to the base 2 of 4 can be written as 2 squared. So log to the base 2 of 7 plus log to the base 2 of 2 squared over p. Now obviously I could have changed this one already, but that term there will actually simplify to p. Log to the base 2 of 2 squared will bring down the 2. So we have 2 times log to the base 2 of 2 all over p, which simplifies to p plus 2 times 1, which is 2 over p. So that's our 3 terms in terms of p. We just need to bring them together. So we need to put our p plus 1 plus then our p minus 3 over 2. If you wanted to, you can put a bracket around each one just so you have each term sort of separated. We do have a minus here, we just need to be careful of. So the minus, and then our last term that we got, p plus 2 over p. And we can simplify that a little bit more, maybe bring our p's together that we can. We got p plus p here is 2p. We've got a 1, and we've got a minus 3 over 2. So we could put that in there as well, or a little bit of manipulation on here. So 2p, We have a 1 and a minus 3 over 2, which we can bring together straight away there as minus a half. Dealing with this fraction on the end, we could change that. I mean, you could have done that all in one go if you wanted to, but we can separate that out into two separate fractions. P over P will give me 1. The plus 2 over P, there's not much I can do with that, but don't forget the minus multiplies into that. So we end up with the 2P at the beginning. We have the minus a half minus 1 from here, which gives me minus 3 over 2. And then it's going to be a minus 2 over P. And that's my final answer on that one. And that was 10. Question 6a, part 1 gives us this to fully factorize. So I suppose we start off with doing whatever little factorizing we think we might be able to do. With the numerator there, we can take a 3 out. We're left with x cubed minus 8 on the top and x minus 2 on the bottom. There's nothing I can do with the x minus 2. So it's all to do with the numerator and what we can figure out that we can do with that. It isn't a difference of two squares because we have an x cubed. But actually from that we realize that 8 can be written as something cubed. So 3 can be multiplied by x cubed minus 2 cubed inside the bracket. And what we have is the difference of two cubes, which isn't something that is in your log tables book, something that we need to remember. So if I have, for example, a cubed minus b cubed, I can factorize that as a minus b multiplied by a squared plus ab plus b squared. So we need to remember that. So with that in mind, we look to factorize what we have. The 3 is going to stay as it is. My a in this case is my x, my b is my 2. So I'm going to end up with x minus 2 in the first bracket, and then it's x squared plus 2x plus 4. And that's my factorization of the top, the numerator. And what we notice is that we have the x minus 2 and the x minus 2. That will cancel each other out. So we're just left with 3 times x squared plus 2x plus 4. And that's my final answer. And that was 5 marks. Question 6a, part 2. We're asked to use the fraction that was given to us in part 1. And we're asked to integrate it with the limits of 2 and 0. So what we can do is take our answer from part 1 first of all. So we're going to integrate, and we have 3 times x squared plus 2x plus 4 with respect to x. So what we can do first of all is this 3 that's being multiplied can move out to the outside, and we can just focus on integrating what's here. So we're going to integrate the x squared, 2x, and the 4 with respect to x. So we get 3, and in our bracket, integrating, we increase the power by 1 and divide by the new power. So we end up with x to the power of 3 over 3 plus 2x squared over 2 and plus 4. I suppose we can increase the power to 1. You can write it as over 1 if you wanted to, and my limits are 2 and 0. And we're going to fill in for those limits in a second, but actually what we can do here is probably multiply in my 3 straight away, just to make that a little bit easier. So if I multiply my 3 in, I end up with x cubed, so 3's cancel here, 2 over 2, they cancel each other to 1, multiplied by 3, though we still have the plus 3x squared, and then it'll be a plus 12x on the end. And again, my limits are 2 and 0. So now we can fill into our limits fairly straightforward. So 2 cubed plus 3 times 2 squared plus 12 times 2. Take away 0 cubed plus 3 times 0 squared plus 12 times 0. So in our first bracket, we end up with 8 plus 12 plus 24, and everything here cancels out to 0. We can just write it anyway, and that works out to be 44 as our final answer. And that was 5 marks. Question 6b gives us this diagram of two different curves. meeting at the point P. And part 1 is asking us to find the coordinates of P, which is the point of intersection of those two curves. So when we have a point of intersection, if we have the equations of the two curves, what we can do is put them equal to each other. So e to the power of x is equal to 3e to the power of minus x plus 2. The first thing I would do is change this negative power to a positive power. So e to the power of x will be equal to 3 over e to the power of positive x and plus 2. And the next thing I would do is to multiply all the way across by e to the power of x, just so we don't have the fraction. So that's going to give us e to the x to be squared is equal to 3 plus 2e to the x. We bring that all to one side, we end up with something that looks very similar to a quadratic equation equal to 0. So we have a term which is squared, we have another term here, which is e to the power of x, and then we have a number on the end equal to 0. And what we can look to do is pretty much factorize that. If it makes it a little bit easier for you to see that, what we could do is say let y equal to e to the power of x. So you have y squared minus 2y minus 3 equals 0. Now it looks a little bit more simpler to factorize. So you'd open up your two brackets, two factors, and multiply to give me minus 3 and add to give me a minus 2. So we'll be looking at minus 3 and plus 1. Okay, so if we apply that back to what we have here, we would have e to the x minus 3 in one bracket and e to the x plus 1 in the other bracket when we factorize. And solving that, we have e to the x will be equal to 3, and we have e to the x will be equal to minus 1. Going from exponential to logs, what we can see is that x would be equal to log to the base e of 3. In this situation here, what we would end up with is x is equal to log to the base e of negative 1, which is impossible. So we won't continue with that particular solution because it's just not possible to get the natural log of a negative number. So we're going to use this one here. Okay, so what we have there is we have our x value of our coordinate or point. We need to find the y value. So going to either of the two equations, the easiest one is probably y equals e to the power of x. Filling in our value of x, we have y equals e to the power of log to the base e of 3. And you can put that into your calculator and we get y is equal to 3. So our coordinate we get for p is log to the base e of 3, 3. And that was 10 marks. B part 2 then asks us to hence find the area of the shaded region. So we're going to use integration to help us do this. And we're going to use obviously some of our answer from part 1 as well to help us with our limits. So what we're going to integrate is we're going to integrate using our limit that we got using our x value. So log to the base e of 3. X value of p from the previous question, and 0 representing where the y-axis is. So that's using those from the x-axis. And we're going to integrate the first function of 3e to the power of negative x plus 2 minus our second function, which is e to the power of x. So we're going to integrate that with respect to x. So integrating this, what we're going to end up with is integrating the 3e to the power of negative x using our log tables book to help us here. So that's going to become minus 3e to the power of minus x plus 2x. And then we would just have a minus e to the x. And using our limits then of log to the base e of 3 and 0. So filling in those limits, we would end up with minus 3 e to the power of minus log to the base e of 3 plus 2 times log to the base e of 3 minus e to the power log to the base e of 3. Minus, on the other side, the limit is going to be minus 3 e to the power of 0 minus 0. You can just write that as 0 plus 2 times 0 minus e to the power of 0. So working out what we can of that, that's going to leave us with minus 3 times 1/3 plus log to the base e of 3 to the power of 2, if we use our rules of logs there, and minus 3. Minus on the other side, we are left with minus 3 minus 1. So that gives us minus 1 plus the log to the base e of 9 minus 3, and over here we end up with, this is minus 4, but negative on the outside gives us a plus 4. So actually everything cancels there. The minus 3, minus 1 and the 4 all cancel each other out, and we're actually just left with log to the base e of 9, which works out as, on our calculator, 2.1972245777. And that's our answer. And that was 10 marks. Question 7, we're given that the value of V in euro of a painting is modelled by this equation, where A and P are real numbers and T is the number of years after the 1st of January 2020. So we're given two values here at different times. So we're given that it's valued at €32,000 on the 1st of January 2004 and €50,000 on the 1st of January 2011. We're asked first of all to work out the value of P. So if we fill in the information that we have here for these two valuations into our formula. So for example, V of 4, T being 4 years after 2020, or sorry, 2000, 1st of January 2000. So V of 4 would be A P to the power of 4, and we know that that answer is 32,000. Do the exact same thing when T is 11, and we have AP to the power of 11, and that's equal to 50,000. And what we can do with that then is we can say, well, they're in proportion to each other. So if I were to say put AP to the power of 11 over AP to the power of 4, that would be the same as putting 50,000 over 32,000. What that allows me to then do is to do some cancelling here to just find P. My two A's will cancel each other, divide the top and bottom by A. And here we have our rows of indices that we can use. When we're dividing, we take away. So that's going to give me P to the power of 7 is equal to, and using my calculator, I can simplify this to 25 over 16. And if I want to find out what P is, I'm going to find the 7th root using my calculator of 25 over 16. And it does tell me in the question to leave my answer correct to 4 decimal places. So I'm going to leave it as 1.0658. And that was 10 marks. Part 2, then we're asked to show that A is equal to 24,800, correct in nearest whole number. So filling back into my formula and using the value that I've got here for P, so A multiplied by 1.0658 to the power of 4 would be equal to 32,000. So just taking one of those valuations that I was given to in the question. So rearranging that, A would be equal to 32,000 divided by 1.0658 to the power of 4. When we put that into our calculator, we get 24,799.739. Now it does say correct to the nearest whole number. So correct to the nearest whole number, that would round to 24800. Exactly what they asked me for in the question. Now this is not marked by itself. It goes with the next question. So both of these together are actually 5 marks. Currently, if I was just leaving it like that and I didn't answer part 3, for example, I would have 3 out of the 5 marks so far. But part 3 here, asked me to explain what the value of A and the value of P represent in this model. So the value of A, so A being equal to 24,800, is the value of the painting at the very start. So the value on 1st of January 2000. So my starting value on the painting. And asked me what is P. So P again is 1.0658. And that's the factor of which the value of the painting rises annually. Or basically the rate at which the value changes. Okay, every year. So we're talking as a percentage, we're talking about a 6.58%. If we wanted to go into that level of detail, we could. But it's a 6.58% annual increase in the value of the painting. So altogether, that will give me 5 marks. Part 4 of this question asks me to find the year in which the value of the painting first exceeds €100,000. So filling into the formula with the information that I have, 24,800 multiplied by 1.0658. So what I'm looking for here is T. I don't have T, but I'm going to put that equal to 100,000. And I'm going to solve for T. So the first thing I can do there is divide both sides by 24,800. And we can do that on our calculator. We want to, we can simplify it down at least to a fraction of 125 over 31. If I want to find out what T is, I'm going to use logs here to help me. So what I can do is I can say that T would be equal to the log to the base of 1.0658 of 125 over 31. And when I work that out, I can get 21.88013207. So it exceeds 100,000 in the year 2021. Now that question was 5 marks. Part 5, we're asked to find the value of dB/dt when t is equal to 5, correct the nearest whole number and explain what this figure represents. So the first thing is dealing with what we have. V of t is equal to 24,800 times 1.0658 to the power of t. So we have to differentiate this. So we're going to use the product rule to help us do that. So dB/dt would be equal to 24,800 times 1.0658 square t, and we're multiplying that then by the log to the base e of 1.0658. Working that out, we get 1,580.397134 multiplied by 1.0658 to the power of t. Okay, we want to find dB/dt at t equals 5. So when t equals 5, what are we going to have? We're going to have 1,580.397134 times 1.0658 to the power of 5. And when we work that out, we get 2,173.43. And that's the nearest whole number. Would be 2,173. And what does that represent? Well, basically that represents the rate of change of the price on the 1st of January 2005. So we can write that in the bottom. This is the rate of change of the price on the 1st of January 2005. Okay, anywhere where we're having a question where we're using calculus and we're asked what does this represent, the phrase rate of change is really important there. That question was worth 5 marks. At 6 here, we're told that the painting was sold in an auction on the 1st of January 2026 for €2,300. The increase in value of the period from the 1st of January 2000 to the 1st of January 2026 is equivalent to the increase in value of R% each year, compounded annually. So where R is real and is constant. Work out the value of R. So give your answer correct in nearest whole number. So with that, lots of information, take it bit by bit. What we would say here is that the V of 26, so 26 years after the 1st of January 2000, they're telling me in this question is 230,000. So that could be something just to jot down and make note of. We already know a few of the other values. For example, at the very start, its value was 24,800. So V of 0, when T is 0, it's 24,800. Now, if we're talking about compounded annually, we can go to our log tables book and we can get a formula there to help us. And that formula we can read there. So F equals P times 1 plus I to the power of T. So we can use that formula to help us because I know that the value of 230,000 will be equal to the starting value, 24,800, multiplied by 1 plus R, which whatever R is, we're trying to find. So the R being the rate. We could leave that as I as well, but we understand that that means the rate, and to the power of 26, because again, that's the value after 26 years. And we can do a little bit of rearranging here to help us. So we're going to bring over or divide both sides by 24,800. And that's equal to 1 plus R to the power of 26. I can find the 26th root using my calculator of that fraction. Again, you could simplify that first if you wanted to, but as long as we have an equivalent fraction, that's absolutely fine. And that will be equal to 1 plus R. Okay, when we put that into our calculator, we get 1.089439 is equal to 1 plus R. And if I want to find out what R is, then I'm going to take away 1 from both sides. Just going to write it up here. And I would end up with 0.089439 is equal to R. Now, they asked me to give my answer correct in nearest whole number. If I look at that as a rate, we're talking about this being a percentage. That would round to 0.09 as a rate. And we're looking at a 9% rate. And that question was worth 10 marks. Last part of this question, part B, €5,000 invested for 3 years at an annual equivalent rate or AER of 3.2%. At the end of the first year, a sum of money is withdrawn. Balance remains in the account for another 2 years, after which the account is closed. The final balance in the account when it is closed is equal to the sum of money withdrawn at the end of the first year. So we have to work out the sum of money withdrawn at the end of the first year and give your answer correct to the nearest cent. Okay, so taking the information that they've given to me there at the very, very beginning. So if we look at it as year 1 starting off, so we started off with 5,000. And if I use my interest formula, my compound interest formula, our rate is 3.2%. So we're talking about 0.032, and we are talking about just 1 year. Okay, so what did that investment make after 1 year is what we're calculating here. So when I work that out, again, it's just 5,000 multiplied by 1.032. You could do that all in one go. And we end up with €5,160. So that was the value of the investment at the end of the first year. Now, an amount of money was withdrawn. We don't know what that amount is. So anytime in maths, if we don't know something, let's give it a letter. Okay, let's give it something to represent itself. So say we withdraw X euro. So what we have is we have 5,160 minus X left in the account after the first year. So that's the amount then that's going to be taken on to the second year. So if we, and indeed, I'm following on then from that, the third year. So if we're talking about years 2 and 3, okay, this is going to be our starting amount. Okay, so we're going to have 5,160 minus the withdrawn amount of X. The rate isn't changing, so that's still 1.032 to the power of 2 this time. Why 2? Because we're looking at, now we have 2 years that we're going to calculate. Okay, and we do what we can with that. We can work out this bracket here, the 1.0232032 to the power of 2. So we get 5,160 minus X multiplied by 1.065024. And then we can multiply that into our bracket. So what we end up with is 5,495.52384 minus 1.065024. Okay. The next thing that we're told in the question is that the balance, okay, when it is closed, so at the end of the third year, is equal to the sum withdrawn. Now, we have said that the sum withdrawn is X. This is my balance at the end of the third year. And that's what's going to be at the end of before the account is closed. So actually, I can put that equal to X then, because that's what the question tells me. So X is equal to then the 5495.52384 minus 1.065024X. And we're hopefully going to be able to solve it for X in this case. So let's keep the X's together. What we end up with here is X plus 1.065024X is equal to 5,495.52384. Can't really add these together as such, but what we can do is we can factorize this side and take the X out, and that suits what we need. And we're left with 1 plus 1.065024 in a bracket is equal to 5,495.52384 on the other side. And that allows us to isolate X, because we can bring over the bracket and we can divide on the right hand side, or divide both sides by that bracket. Again, I could add that together as well at the same time if I wanted to, as long as, so we make that 2.06524. We can work that out on our calculator. We get 2,661.2396. We want our answer correct to the nearest cent. So we're looking at X is equal to 2661.24. That's our amount withdrawn at the end of the first year. Now that question was worth 15 marks altogether. Question 8, we're told that two sailors are designing new flags for their boats. So part A here, the first sailor Ian wants his flag to feature a blue triangle, and we can see it on the right hand side here, the APQ, on a white rectangle background of ABCD. And the information given to me is that AB is equal to 60, AD is equal to 80 centimeters, P is a point on BC, down here, such that BP is equal to 8 centimeters, and Q is a point on CD such that QC is equal to X centimeters as well. And we're asked to find the areas of 3 of the triangles here, so basically the triangles that are not shaded in terms of X. So when we're finding the area of a triangle, the most basic way is half the base times the height, and we're actually going to use that here. So if we look at the first triangle of A, B, P first, The area will be half multiplied by x multiplied by 60, which is 30x centimeters squared. So that's the first one done. The next triangle is PCQ, and the area of that will be half 80 minus x. Okay, so if we have a quick look at that, PCQ is here. We know that this full length here is 80. We know that this is x. So this length here of PC that we want to use is going to be 80 take away x. So that's my base and multiplied by my height, which again is x. And that can simplify to 80x minus x squared over 2. Okay, and the last one then, my triangle of AQD has an area of half 80. So AQD is this top one here. We don't have this measurement, but we do know that this length here is 60. This length here is x. So QD must be 60 minus x. And we multiply that out, you get 4,800 minus 80x all over 2, and that gets simplified to 2,400 minus 40x. So those are my 3 areas. Can we just put our units just to make sure? And that question was worth 10. So we're asked to hence show that the area of the triangle APQ is equal to 2,400 minus 30x plus x squared over 2. So hence means we're going to use our values that we had before. So the area of the triangle they're talking about is the shaded triangle. And what we should understand if we look at our diagram, to get that area of the shaded triangle, we would need the area of the overall rectangle and take away the 3 areas that we just found. So that's what we're going to do. So if we're looking at the rectangle, the area of that rectangle can be calculated as 80 multiplied by 60, which is 4,800 centimeters squared. So that's the overall area of the flag. And we're going to take away the 3 areas that we've just found. So the triangle APQ will be equal to that 4,800 minus the 30x minus, and I'm going to put it in a bracket just to make sure that any of the signs are correct. So minus the 80x minus x squared over 2, and again minus 2,400 minus 40x. And do take care just to put them in a bracket, because that minus on the outside of that bracket is going to change the signs here. Okay, so work out what we can and try and tidy that up. What I'm going to do here actually, and I could have done it up in the previous question if I wanted to, I'm actually going to split this into 2 separate fractions. So 80x over 2, which will give me minus 40x. And I'm going to split this into x squared over 2. So I'm literally just writing as 2 separate fractions. Do be careful though, because the minus is multiplying into that, and 2 negatives there will actually give you a plus x squared over 2. Okay, and the same here, that minus is multiplying into that bracket, so we get a minus 2,400, and again, minus by minus will give me a plus 40x. So that's where you're really just going to make mistakes there if you're not a little bit more careful and put brackets around your different elements of this. And we tidy up what we can. So bringing the numbers together here, we get 2,400, which is perfect. That's exactly what we need. The minus 30x is there, but we have a minus 40x plus 40x. They're actually going to cancel each other out, leaving me with the minus 30x that I need. Perfect. And again, all that's left is the plus x squared over 2. And that's exactly what the question is asking me to have. And that question was 5 marks. So part 3 in this question has asked me to find the minimum area of the triangle APQ. Anywhere where we see a reference to minimum or maximum, we should be thinking along the lines of differentiation, so calculus here. So let's go back to our formula. We have A is equal to 2,400 minus 30x plus x squared over 2. So that represents the area of the triangle APQ. And what I want to do here is, first of all, differentiate that. So I'm finding dA dx. when I differentiate 2,400, return goes to 0, so we don't write that down. Minus 30x to be differentiated will just leave me with minus 30. So remember what you're doing here is you're bringing down the power, multiplying, and reducing the power by 1. And here, the x squared over 2, bring down the power and multiply, you get 2x, reduce the power by 1, so I'm just going to leave it as x, and still over 2. And we can simplify that a little bit further as minus 30 plus x. So that's my differential. What we should understand is that at the minimum point, okay, my differential, so in this case dA dx, is equal to 0. The same refers to if it's a maximum as well. So we're putting that first differential equal to 0 in that case. So minus 30 plus x is equal to 0, so x is equal to positive 30. Now that's not my final answer. What I need to do is work out the minimum area. So what it's asking me to do there is to take that value, that's the value of x at the minimum, put that back into my original formula for area. So 2,400 minus 30 times by 30 plus 30 squared over 2. And we can put that into our calculator. We get 1,950 centimeters squared. And that's our minimum area for the triangle APQ. And that question was worth 5 marks. Question B, part 1, tells me that the second sailor, Eve, wants her flag to feature a red rectangle, which is a shaded rectangle here, on a white right-angled triangular background, as shown in the diagram. So we're told that EF is equal to 60 centimeters, EG is 30 centimeters, and we have an angle of EFG of 30 degrees. And we're asked to show this. We're asked to show that y is equal to 60 minus 4x over root 3. Anytime we get a question with a diagram and we're not maybe really sure how to start it, this could be a good example. What can you find out from this diagram? Is there anything that you can show the examiner that you're able to do? So we have a right angle triangle. If we just look at that, we have a 30-degree angle. Here we know we have a 90-degree angle. So the first thing that we could refer to is that this angle up here is 60 degrees because the angles have to add up to 180. So it's just thinking about what you can do. What piece of information could you find? Now, continuing on with that idea, we have a right angle triangle. So what can we do with a right angle triangle? First thing you're thinking about maybe is Pythagoras, or maybe you might think about using our sine, cos, or tan ratios. Because we have angles here, I think we'll look at the sine, cos, tan ratios. I'm going to pick tan, and what I'm referring to here is this small triangle down here. Okay, so the very bottom right angle triangle that we have here. We have an angle of 30, we have a side measurement here of x. I don't know what this measurement is here, and that would be useful. Because if I want to find out what y is, knowing some of the measurements of the length EF would be very helpful there. So I'm going to give it a letter, and I'm just going to call it T. It doesn't matter what letter, just not X or Y in this case. So if I want to find out or work out what T is there, so X is my opposite, T will be my adjacent. So we're looking at the tan of 30 degrees being equal to X over T. The tan of 30 degrees is 1 over root 3, so that's equal to X over T. And I just want to get T in terms of X. So we're going to cross multiply there. T will be equal to X multiplied by root 3. Now you could write that as root 3x as well. It doesn't matter. We're multiplying those. Where else can I go? So I'm also then going to look at this really small triangle up here. Again, it's a right angle triangle. I've got a 60-degree angle now that I looked at. I don't know what this measurement is here. Okay, again, I'm going to give it a letter and I'm just going to call it S. Could be any letter you want. Again, not X or Y. And I do know that this measurement is X because that's a rectangle. Apologies for the bell. Because it's a rectangle, opposite sides are equal, and that is x. So looking in that triangle, I can tell you that the tan of 60 degrees is equal to opposite of x over the adjacent. In this case, I'm using s as my letter. And again, the exact same idea. tan of 60 is equal to root 3, which is x over s. I just want s, so s would be equal to x over root 3. So how does that help me? Well, I now have, in terms of x, I now have something to represent the s and the t. If I want to know what y is, I can tell you that y is equal to this whole length here of 60 degrees minus those two values. So y will be equal to 60, the full length of EF, okay, minus, I'm going to write it as root 3x in this case, and minus x over root 3. Okay, so that's my starting point. Now we can see that that's a little bit different. The 60 is perfect. We've got that right. This is the bit that maybe we need to do a little bit of work on. So we're looking at maybe bringing these two bits together and seeing if we can maybe get a common denominator. Now I could say that that is over 1 and looking at it and use that to help me with a common denominator to bring these together. So my common denominator here is going to be root 3. So we're going to have minus something over root 3 and minus, and I already have that as my common denominator there. So if I want to change this fraction to be over root 3, I'm multiplying the denominator by root 3, so I need to multiply the numerator by root 3. So what I end up with is 3x. Root 3 times root 3 will just cancel the square root. Where do I go from there? Well, y will be equal to 60 minus, bring it all together. What do I have? I have 3x, take away x. That's going to leave me with, sorry, minus 3x minus x. It's going to leave me with a minus 4x on the top. And that's exactly what I need for the question. And that was worth 10 marks. Part 2, a very similar question, apart from they refer to maximum area of the red rectangle. In the previous question, previous part of the question, we were looking at the minimum area. And again, when we see that maximum or minimum, we look and we know that we're going to use calculus at some point. First of all, though, I don't have something that represents or an expression that represents the area of the rectangle as such. Now, I do know that the area will be equal to x times y. Okay, but I don't want to have the y in there. I know though from the previous part of the question that I have an expression to represent what y is. So I can change that to x times 60 minus 4x over root 3. And that's my starting point. So my area is equal to 60x minus 4x squared over root 3. Now I have that starting kind of expression or equation that I can now differentiate. So I'm looking at dA dx. And when I differentiate that, I'm getting 60 minus, so bring down the 2, multiply gives me 8x on the top over root 3. Okay, so what do I want to find? I want to find the maximum, and I understand that that is when the differential dA dx is equal to 0. So I'm going to put the 60 minus 8x over root 3 equal to 0. I'm going to solve for x. So that is 60, then will be equal to 8x over root 3. 60 times by root 3 will be equal to 8x, and x will be equal to 60 root 3 over 8. And when I put that in, I mean, I can't get a whole pile of simplifying there, but I could simplify it to 15 root 3 over 2. Okay, so that's my value of x. And I know from the previous question, that's not my final answer. That's my value of x when it's at its maximum. So what I need to do then is go back and fill in my value of x back into my area formula. Okay, so a will be equal to 60 times by 15 root 3 over 2 minus 4 times 15 root 3 over 2 to be squared all over root 3. Okay, simplify, work out what you can. We end up with 450 root 3. We're using our calculator to do this. Minus 4 times 675 over 4. 1 over root 3. You can take your time and just do it bit by bit. You could try and type it into your calculator all in one go, but just be making sure that we're typing it in correctly. So 450 root 3, working out this fraction here, we get minus 675 over root 3. And we get a final answer here of 389.7114317 centimeters squared. And that gives me my maximum area of the red rectangle. And that question was worth 10 marks. Part 3, the last part of this question asks me to verify that this area is half the area of the triangle EFG. Many different ways that you could probably attempt to do this question. The way I would look at it is, can I get the area of the triangle EFG? And again, many different ways that you might attempt to do that. I'm going to use the half AB sine C formula. So I have an angle of, a side length of 30 and a side length of 60, and I have an angle of 60 in between. So I'm just going to use that. And I end up with 900 multiplied by root 3 over 2, which gives me an area of 450 root 3 centimeters squared. Now, because I have my area here as a decimal, working that out, 779.4228634. So that's the area of my triangle EFG. I have to verify that this answer here that I got previously for the maximum area of the red rectangle is half of that. Well, the area then halved. Okay, so if I do 4228634, if I divide that by 2, then what I end up with is 389.7114317, which is equal to the area of the red rectangle. Okay, so the area that we got for the red rectangle is half the area of the triangle EFG, and that was worth 5 marks. Question 9, part 1. So we're given that speed v in meters per second of a battery-powered model car traveling in a straight line is modeled by this function, where t is the time in seconds between 0 and 6 inclusive. So we're asked to first of all fill in the table below to show the values of v of t for the given values of t, and give each value correct to one decimal place where appropriate. So in this question, we're substituting in values for t into the formula that we have. We can use our calculator to do that, but pretty much what we're typing in. So for example, for when t is 0, we're just going to end up actually with 16 take away 10, because 16 minus 10 times e to the power of minus a half times by 0. Well, we just end up with e to the power of 0 here, which we understand is 1. So that's what gives us a value of 6 for the first one. And we can use our calculator just changing this value each time. So when t is equal to 2, we should get 12.3. When t is equal to 3, we should get 13.8. And the last one, 15.2, when t is equal to 5. And using your calculator correctly there, shouldn't be any problem with that. Now, when it comes to marks, this question goes with the next one. So what we have here is filling in the table of values, and then in part 2 it asks us to hence draw the graph of this function y equals v of t between t being 0 and 6 inclusive. So anytime we're asked to draw a graph, get a pencil, make sure you use a pencil, because if you make a mistake with a pen, can't really move that out. So we're going to graph our function here and see what we end up with. So using our values, 0 first is if t is 0 and the speed is 6. So t being 0 starting here and 6 on what we would naturally call our y-axis. Okay, and we keep going with all of the other values that we have. So when t is 1, given to us is 9.9. So as accurately as you can, making sure that we're plotting these values. When t is 2, we worked out that it's 12.3. Just think about it when you're looking at your scale here. That line in between will be 13. So you're trying to make it as accurate as possible. When t is 3, we have 13.8. When t is 4, 14.6. When t is 5, we're at 15.2. And when t is 6, we're at 15.5. Okay, and what we should see is that curve going up. And we join that together nice and carefully. We can do it very slowly, must be freehand, joining each of those points together. Now, those two parts to that question, so both doing the table and doing the graph, are worth 10 marks altogether. Grade 3, we're asked to use the trapezoidal rule to estimate the area between B of t and the t-axis, for t being between 0 and 6, and i.e. the distance travelled by the model car in this time. So if we look in our log tables book on page 12, we can see our trapezoidal rule here. So we're going to fill into that. Okay, so if I leave that there so you can see what I'm doing. So what we have is A will be equal to h over 2. Our y1 will be our 6, and so on. 15.5 is our yn, so our n value. So that's our value when t is 0 and our value when t is 6, plus 2 times 9.9 plus 12.3 plus 13.8 plus 14.6 plus 15.2. So those are all my values in between. So those are my y2, y3, y4, all the way up until basically when t is 5, okay, the yn minus 1. So that's filling into my trapezoidal rule using page 12 in our log tables book. And now we need to work that out. Okay, so what can we do? We can bring some of it together. So we end up with 21.5. Okay, I bring the 6 and the 15.5 together, plus 2 times, working out what's inside the bracket, 65.8. So again, working out what's inside the square bracket this time, we'll end up at 21.5 plus 131.6. So A is equal to, now my H actually I didn't fill in and I could have filled in before now. But my h is the distance between, if we go back to our diagram here, it's the distance between each of these points and readings that I have. And that would mean that h is equal to 1. So I could have filled that in sooner, but I'm going to fill it in now. So we have a half times by 153.1 when I bring that bracket together. Working that out, my area would be 76.55 meters. And that question was worth 5 marks. Number 4, we're asked to use integration to find the actual distance travelled by the model car in this time. So if I go back to my function, v of t is equal to 16 minus 10 e to the power of minus a half t. So we need to integrate v of t with respect to t. Okay, so when I integrate, and we're using our limits as 0 and 6, of 16 minus 10 e to the power of minus a half t with respect to t. Okay, when I integrate that, what do I end up with? I end up with 16t minus 10 times integral here is 1 over my number, which is minus 1 over half, minus 1 half, times e to the power of minus a half t, and again my limits are 0 and 6. A little bit of tidying up here. That's going to give me 16t plus, got me some double negative here, so plus, when I work this out, it ends up as being 2, so multiplying that by the 10 would give me 20 e to the power of minus a half t, and again, my limits of 6 and 0. And now I'm going to fill in my limits. So limit of 6, 16 times 6 plus 20 e to the power of minus a half times 6 minus 16 times 0 plus 20 e to the power of minus a half times 0. And what we end up with is 96 plus 0.995741 minus 20, which is equal to 76.995741. Now, this question by itself is, you don't get marks by itself necessarily. It actually goes with the next question, which we'll look at now. So the next part, V, it asks you, using your answers to parts 3 and 4, find the percentage error in the estimate for the distance travelled by the model car and give your answer correct to 1 decimal place. So let's look at what the error would be. My 76.995741 is the actual distance travelled minus previous one using the trapezoidal rule, which is an estimate of 76.55 meters. So that's an error of 0.445741. So if I want to work out what my percentage error is, I'm going to put that value, so 0.445741 over the actual area. And I'm going to multiply it by 100 to make it a percentage. So we end up with 0.5789, correct to 1 decimal place, 0.6%. And that's my percentage error. Now this answer and the previous one altogether are 10 marks. So that's for parts IB and V in this question. There were 10 marks. So the next part, VI, we're asked to use calculus to find an expression for the acceleration of the model car after t seconds, and hence find the length of time for which the acceleration is less than 1 meters per second squared, and give your answer correct to 2 decimal places. So my V of t is equal to 16 minus 10 times e to the power of minus a half t. So using calculus, we're going to find V dash t. That would give me, well, if I wanted to write it 0 first, don't necessarily need to write that, minus a half times minus 10 e to the power of minus a half t. And when I work that out, double negative gives me a positive, 10 divided by 2 gives me 5 e to the power of minus a half t. So that's my differential. So it then says, and hence find the length of time for which the acceleration is less than 1 meters per second squared. So where is 5 e to the power of minus a half t less than 1? So a little bit of work on that. We can say we'll bring over the 5 or divide both sides by 5. And now we can use logs. So natural log, or log to the base e, of both sides of this inequality. And that will help us solve it. So using our rules here, we can say that a half t log to the base e of e is less than, working this side out, minus 1.609437912. Okay, so we have a half t log to the base e of e, we understand, is 1. So we're left then with our number on the other side. So if I want to solve for t, what I could do first of all is deal with the fact that there are 2 negatives here. So I can change the sign on both sides, but do remember that when we do that with an inequality, we will change the direction of the inequality. So we have a half t will now be greater than 1.609437912. So t will be greater than 3.218875.825. That's when we bring over or we multiply both sides. Okay, so what do we have? we have that the time is greater than 3.2188. So what we need to do is take the 6 seconds minus that, and that gives us 2.781124.175, so 2.78 seconds. So that's the length of time for which the acceleration is less than 1 meter per second squared. Well, that question was worth 10 marks. Part 7 asks us to find the average speed of the model car at the intervals when t is greater than or equal to 3, less than or equal to 6. And give your answer correct to 2 decimal places. So the average of a function formula isn't given to our log tables book, but it's 1 over b minus a integral limits of b and a of the function with respect to x. So that's the formula we need to use here. So in this case, my a is 3 and my b is 6. So filling that in, I have 1 over 6 minus 3 times the integral between 6 and 3 of 16 minus 10 to the power of minus a half t with respect to t in this case. So we end up with 1/3, and the integral we have is 16t plus 20 e to the power of minus a half t between the limits of 6 and 3. Filling that in, using our limit of 6 first, and don't forget we put the 1/3 as well with our limit of 3. We get first bracket 96 plus 0.995741 minus a half times 48 plus 4.462603. When we work all that out, we should get an answer. I'll do it step by step first. So the first bracket is 96.995741 minus a third times 52.462603. If we put that into our calculator, we end up with 14.84437933, and rounded to 2 decimal places, 14.84 meters per second. And that question is worth 10 marks. Part 8, last part of this question, the speed of the model car over the interval when t is greater than or equal to 0, less than or equal to 6, with the car starting from rest, is modelled by the function v of t. And we're asked to find the value of k correct to 3 decimal places. So looking at our inequalities that we have here, our ranges of value, this one is starting at 0, this one is starting at 1. So where they both will, I suppose, start at the same point is where t is equal to 1. So I'm going to look at filling in when t is equal to 1 into both of these functions that we have here. So v of 1, we're going to have e to the power of k multiplied by 1 minus 1, which is e to the power of k minus 1. And we also then have 16 minus 10 e to the power of minus a times 1, which works out as 16 minus 6.065306, which is 9.934693403. So they're both equal to each other because of what we filled in and what we know. So e to the power of k minus 1 can be put equal to 9.934693,403, and we can solve for k. So e to the power k will be equal to 10.9346933403. So k will be equal to the log to the base e of that number. So k will be equal to 2.3919401616, and we're asked to give it to 3 decimal places, so 2.392. And that question is worth 5 marks. Question 10a. So we're given the first 3 stages of an infinite pattern which creates the Koch snowflake are shown below, and the pattern begins with an equilateral triangle of side length of 1 unit. So each stage is formed by splitting each side into 3 equal parts, then replacing the middle 1/3 with 2 sides of a new smaller equilateral triangle pointing outwards. The process is repeated with each straight edge split into 3 and the middle 1/3 replaced with a smaller equilateral triangle as described above. So we have the diagram here of stage 1, 2 and 3. And we're asked the first part in part A. The table below shows the length of each side, the number of sides, and the perimeter of the snowflake in each stage. So we're asked to complete the table. So if we look at the length of the side first, the length of the side we're told here is 1 unit. And for the second stage, we're told that is a length of 1/3, which makes sense because it's split into 3. Well, then we know that there's a split of 3 here as well. So we end up at 1, 2, 3, 4, 5, 6 in theory, 7, 8, 9. So it's 1/9, so 1/9. What we can see happening in here is a sequence of the length of sides where we're multiplying by 1/3. So if we multiply by 1/3 again, we would expect to have 1/27 as our length of side for the stage 4. Moving on then to the number of sides. So in the first stage, we have 3. In the second stage, we can count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is our answer for stage 2. And we can see here we have 48. Again, we can look at it as a sequence. What is happening in this sequence? We're multiplying by 4 each time, and we get 192 as stage 4. And the last one is perimeter. So we have a perimeter of 3. We have a perimeter of 4. What we're doing there is multiplying the length of the side by the number of sides that we have. So what we should end up with is 16/3 and then 64/9 for the last one. Altogether, that question is worth 10 marks. Part 1, we're asked to write an expression in n for the length of each side in the nth stage of the pattern. So we're talking about the length of the side. So if we look back at the sequence that we might have there, we have 1, 1/3, 1/9, and 1/27, and so on. Okay, now if we look at our nth term, we can say it's ar n to the power, ar to the power of n minus 1. So our first term here is 1, and r is 1/3, so our common difference 1/3. So Tn will be equal to 1 times 1/3 to the power of n minus 1. So Tn will be equal to 1/3 to the power of n minus 1, or you could write that as 1/3 to the power of n minus 1. Either way. And that question is worth 5 marks. Part 2, stage k is the first stage of the pattern in which the number of sides exceeds 1 million. Find the value of k. So here we're talking about the number of sides. So our sequence in that is 3, 12, 48, and 192, and so on. So if we look at our nth term for that sequence, again, we're using our formula, ar to the power of n minus 1. In this case, a is equal to 3, and our common difference, r, is equal to 4 this time. So we multiply by 4 each time. So we fill in what we have, 3 times 4. Now instead of n, we're going to use k for the purpose of this question. So k minus 1. So what we have here is they're asking us that this stage is where the number of sites exceeds 1 million. Okay, so we're going to put that into our inequality. We have, and we're going to say where it's greater than 1 million. Okay, and we're going to try and solve for k. So we're going to have 4 to the power of k minus 1 is greater than 1 million divided by 3. And we're going to use logs to help us solve this. So log to the base 4 of 4k minus 1 is greater than log to the base 4 of 1 million divided by 3. So using our rules of logs, k minus 1, bring it down, log to the base 4 of 4, we know that that's going to simplify to give us 1. And on this side, if we work this out, we get 9.173303. This simplifies to give me 1, so I have k minus 1 is greater than 9.173303. So k is greater than 10.173303. So if that's the case, if k is greater than 10.173303, then the first stage is when k is equal to 11. That question is worth 10 marks. Part 3. So find the perimeter of the snowflake in the 31st stage and explain what happens to the perimeter in the nth stage as n gets larger. So let's look at the perimeter. We currently have a sequence of 3, 4, 16 over 3, and 64 over 9. Okay, again, looking at our nth term formula, we would be filling in a is equal to 3, and in this case our common difference actually is 4 over 3. So filling that in, Tn will be equal to 3 times 4 over 3 to the power of n minus 1. We are looking for the 31st stage, so instead of n we're going to fill in 31, and we would get an answer of 16798, so 16,798.99702, which would round to 16799 units. So that's the perimeter of the snowflake in the 31st stage. And then asked me to explain what happens to the perimeter in the nth stage as n gets larger. Well, as n gets larger here, the power is increasing, as we would see in our formula. So as n approaches infinity, which basically means it gets as large as it possibly can, we would see that the perimeter gets bigger. And that is worth 5 marks. Part C, the side length of the triangle in stage 1 is 1 unit and the area of the triangle is x. The table below shows the number of new equilateral triangles added in each stage and as a result the increase in the area enclosed. We're asked to complete the table. So new triangles added, we have 3, we have 12, we have 192. So what's happening here is we would see it's being multiplied by 4. So 3 multiplied by 4 gives me 12. Multiply that by 4 gives me 48. And we can double check 4 times 48 gives me 192. So that's the new triangles added. The increase in the area, we will have to look and see what is the, I suppose, common difference here. What's it's being increased by. And one way to find that out will be to take 4 over 27x and divide it by 1/3 x. X is obviously cancelled, and we can put that into our calculator and we get 4 over 9. So we would multiply each term in this sequence by 4 over 9 to get the next. So that's going to give me 16x over 243. And here we would have 64x over 2187. And that is 5 marks to complete that table. Part 2, we're asked to work out the increase in area in terms of x after an infinite number of stages. So the first thing to remember, our r was 4 over 9. We're talking about the sum to infinity is a over 1 minus r. So if we fill in our a was our first term, which was 1/3 x over 1 minus 4 over 9. And we would end up with 1/3 x over 5 over 9, which is the same as 1/3 x multiplied by 9 over 5. And if we apply our skills of dividing fractions, and that will work out as 9x over 15, which simplifies to 3x over 5, or 3/5 x, whichever way you want to write it. And that's worth 5 marks. Part 3, the final part of this question, you have to show that the total area of the snowflake after an infinite number of stages are completed is 2√3 over 5 square units. So the first thing I would look at here is, what is the area of the stage 1 triangle? We know it's an equilateral triangle, so we would look at half times 1, and the sine of the angle. Every angle in an equilateral triangle is 60 degrees. And we know that our side length is 1 unit. So when I fill that in, I get √3 over 4. And I know that that's equal to x, because it says that in the question. So when I use that, I'm going to use it along with the previous answer that I just got. So I know the starting area is x, and I'm adding the increase in the area after an infinite number of stages. So we're adding it to the 3/5 x, or 3x over 5. So that's going to be equal to √3 over 4 plus 3 over 5 times √3 over 4, which is √3 over 4. I suppose we can factorize this as 1 plus 3 over 5, which might be a little bit easier way to work it out. So √3 over 4 times 8 over 5, which is 2√3 over 5. And that question is worth 10 marks.